back to Calculus 3. Actually, we are still in the section, chapter 3, 3.1 and 3.2, vector valued functions. And we were talking about the calculus of a vector valued function. Simply put, I can say the limit of the vector value function, it is the limit of the components. The derivative of vector value function, it is the derivative of the components. Same for the integral. Integral of a vector value function, it is the integral of the corresponding components. Okay, I think I have one more example just to show the integral part. Try to see if I can get there quickly. Yeah, this is the integral example I'm talking about. Find the integral of this vector valued function. Hopefully it's easy enough. The integral of a vector valued function, you calculate the integral of each component, antiderivative, using the fundamental theorem of calculus. Okay, so the antiderivative 2t plus 4, that's t squared plus 4t. Antiderivative 3t squared minus 4t times t cubed minus 2t squared. And using the fundamental theorem of calculus, this is definite integral. So we evaluate the antiderivative at the upper bound and the lower bound. Take the difference. Same for the second component. Antiderivative at the upper bound minus the antiderivative at the lower bound. So for the calculation part, for the upper bound, you replace, for the first component, replace t with 3. And that's I got. Replace t with 1 plus 4. And I think that's 16. Let me double check. 9 plus 12 minus 4. 9 plus 12. 9 plus 12 minus 4. This is 9. Minus 5. Yeah, it makes more sense. So 4 plus 16, that's 4 plus 12, that's 16. I believe I'm correct. Replace the upper bound with, replace the second component, t with t in the second component with t equals 3. 3 cubed minus 2 times 3 squared. And then by replacing t with 1, and the entire thing just tends to be 1 minus 2. 1 plus 4. Yeah, 1 minus 2. And then for the second component, let me double check if I'm correct. 27 minus 18, that's a 9. This is a negative 1 plus 1. Minus a negative 1, that's plus 1. So I believe I'm all right. So this is the example for the integral of vector valued function. Actually, I believe those two sections, so far I covered the two sections. First two sections, chapter 3. I suppose those two sections are relatively easier, so I combine them together. Really not a lot of new things, and certainly for the limit part, you need to know all the limits rule we learned before. Same for the derivative rules and the integral rules. And especially for the derivative, I want to remind like product rule, chain rule, and then for the integral, you needed to know the fundamental theorem of calculus, and then you needed to know integration by substitution and the integration by parts. So this is the beginning part of chapter 3, all for vector valued functions. Thank you for watching.